What if instead of fixing a bad tooth, you could grow a new one? And if you're missing a tooth, what if your body could simply replace it? Well, researchers in Japan has discovered something unexpected. Humans may still have the biological ability to grow new teeth, and they're already shown this process can be activated in mammals by turning off a single molecular brake that normally stops tooth growth. This isn't science fiction. This is actual valid research, and it has already moved beyond the laboratory. So how does this actually work? And how close are we really to seeing this used in everyday life? In this video, I'll break down what scientists have actually achieved, where this research stands right now, and what it could realistically mean for fillings, implants, and dentistry as we know it. To understand why this discovery is such a big deal, we need to talk about something we all take for granted. Humans only get two sets of teeth, baby teeth and adult teeth. Once adult teeth are in, that's it. No replacements, no second chances. That's why dentistry has always been about repair. Fillings, crowns, root canals, implants. We don't regrow teeth, we manage damage. And for decades, that limitation felt permanent. Almost like a law of nature. But in biology, very few things are truly impossible. Sometimes they're just switched off. Here's something that has always bothered scientists. Sharks can regrow teeth endlessly. Some reptiles can, even certain fish can. So the question is, why can they do it, but we can't? Why? Did humans never have that ability? Or did we lose it at some point along the way? The Japanese researchers asked a very specific question. What if humans still have the instructions to grow teeth, but something is actively stopping the process? Let's simplify this. Think of tooth growth like a construction project. During childhood, your body gets the green light from the project leader. Build teeth. The materials arrive. The workers show up. The project gets completed. But once adult teeth are finished, your body puts up a stop sign. That stop sign is controlled by a protein called USAG1. USAG1 acts like a molecular brake. As long as that brake is on, your body is actively told, do not grow more teeth. The breakthrough came when researchers asked, what if we temporarily release the brake? In their research, the team developed a drug designed to block the USAG1. Not permanently, not everywhere in the body, just enough to see what would happen. They studied situations where tooth formation normally does not occur, or where teeth fail to develop properly. And something remarkable happened. When USAG1 was blocked, new teeth started forming. Not bone, not random tissue, actual tooth structures. This was the first strong proof that we still carry the biological ability to form new teeth, if the right signal is unlocked. Now, this is where we need to slow down and be very clear. This research is not about fixing cavities. It does not regrow enamel on damaged teeth. It does not repair chipped or cracked teeth. What this research targets is growing entirely new teeth, primarily in areas where a tooth is missing. Think of it like this. This isn't repairing an old house. It's building a new one on an empty plot of land. This distinction matters because it sets realistic expectations. After establishing that this biological pathway can be activated, the next question was obvious. Could this work safely in humans? And this is where the research takes a very serious turn. In Japan, researchers received approval to begin early human trials. The first participants are adults with missing teeth, often people born without certain teeth. Why start here? Because if a new tooth begins to form where one never existed before, there's no confusion about the results. So at this point, we know three things. 1. The biology is there. 2. Growth pathway can be activated. And 3. It's now being tested in humans for safety. But that leads to the biggest question of all. Is it actually safe? How long would it take? And what does this really mean for implants and modern dentistry? Whenever people hear words like growth and drug in the same sentence, the first reaction is fear, and that's a healthy reaction. So let's talk about safety. The biggest concern researchers had from the very beginning was this. If you turn on growth signals in the body, Could that cause uncontrolled growth somewhere else? That's exactly why USAG1 is so interesting. This protein is not a general growth switch. It's involved specifically in tooth development pathways. In earlier research phases, blocking USAG1 did not show signs of abnormal tissue growth, unwanted bone formation, or effects in other organs. But, and this is important, early safety signals are not the same as long-term safety. That's why the current trials exist. Phase 1 trials are not about effectiveness. They're about answering one question only. Is this safe enough to continue? Another common question is this: how would this even be done in practice? This is not a pill you take at home. This would be a carefully controlled medical treatment. Most likely, a local injection targeting specific areas. The goal is to not activate tooth growth everywhere. The goal is to activate it only where a tooth is missing. And if the process works as hoped, the new tooth would slowly develop over time. Not overnight, not in weeks, but over months. Just like natural tooth development. If this treatment proves safe and effective, it will not be offered to everyone immediately. The first people it's meant to help are those born without certain teeth, a condition called congenital tooth agenesis. For many of these patients, the issue isn't just missing teeth. It's years of feeling different, hiding their smile, or avoiding photos. For them, growing a natural tooth instead of relying on implants could be life-changing. Only later could this potentially expand to other cases of missing teeth. Does this mean dental implants will disappear? Well, no. Implants are proven. They're predictable. They work extremely well. Even if this drug succeeds, implants will remain the standard solution for many years. Think of this like electric cars. They didn't replace gasoline overnight. They slowly changed the future. That's what this research represents. A shift in what might be possible, not an immediate replacement of what already works. Now, let's talk timelines. Even in the best case scenario, this is not something you'll see in clinics next year. Medical development takes time. Multiple trial phases, long-term safety monitoring, and regulatory approvals. Optimistically, we're talking years, not months. And that's not a flaw, that's just how medicine is built. So if you need dental treatment today, the worst thing you can do is wait. Even though this won't help everyone immediately, this research changes dentistry forever. For the first time, we're not just repairing damage, we're exploring regeneration. It tells us something profound. The human body may still carry abilities we thought were gone. And once one door opens in medicine, others tend to follow. While this research is exciting, the truth is, most tooth damage today is caused by everyday habits, not bad luck. And one of the biggest one is brushing the wrong way. In the next video, I show exactly how you should brush your teeth and the common mistakes that silently destroy enamel and gums over time. If you want your teeth to last long enough to even benefit from future breakthroughs like this, watch that video next, and I'll see you there.